Welcome to homework.
Look at the free body diagram before starting to work on the problem. Now, since the ball is at rest, so it's in equilibrium, so we write Newton's second law for the horizontal and vertical directions. And since the ball is in equilibrium, the net force should be equal to 0. Now we solve for these for the forces from these two equations. So for x, we have, and I'm taking the usual coordinate system here. So x is towards right and y is upward. Now for the horizontal equation, we have fb sine theta b to the right, and then we have fa sine theta a, another component along the negative x-axis. And from here we get an expression of, let's say, fb in terms of fa times sine theta a over sine theta b. Now let's write the equation for the vertical direction. So we have fa cos theta a, which is this component of fa, minus fb cos theta b because it points downward, and we have also gravity which points downward, and this is equal to 0. This means that, okay, so let's use this expression of fb in this equation. So doing that, we get so this is the expression of fb that we found above. Then we have a cos theta b multiplied to fb minus mg is equal to 0. Now if you simplify this, you will get fa to be equal to mg sine theta b over cos theta a sine theta b minus sine theta a cos theta b. And the denominator is, in fact, we can write it as sine of theta b minus theta a. This will make our calculations a lot more simple, but you can also go with just this equation and solve it directly by using the values of theta a and theta b. Now we have theta a, let me just write those values. So we have theta b to be equal to 53 degree, and theta b minus theta a is now 31 degree. Mass m is given to be 15 kg, and we have g, which is acceleration due to gravity, and that's equal to 9.8 meter per second square. Now we substitute these values into this equation and get fa to be equal to 228 Newton. Now, one other method to use will be evaluating fa here in terms of fb, theta a and theta b, and using that expression of fa into this equation and solving for fb. Now to solve fb from fa, we will use this value of fa and put it back into this equation, and Doing that, we get Fp to be equal to 10 oops, 7 Newton. So basically what I did is take this value of Fa that we just calculated and theta b and theta a and plug them into this equation and find find Fb from that, which comes out to be 107 Newton.